section 4.4 from the E-text, number 39, and it's about wind speed. There's a tailwind. That means it's going with the wind. There's a Piper aircraft, and it's 600 miles in 3 hours. Okay, RTD. So we have the against, and we have the with. Oh my gosh, I spelled against wrong again. What's my problem? Against. And actually, with. With, it's considered to be a tailwind. This is jargon you don't necessarily need to know, but it is useful. If you go against someone, they call that a headwind because the wind is coming at your head versus a tailwind where the wind is pushing you from the tail. Anyway, so what do we know? With a tailwind, the aircraft can fly 600 miles in 3 hours. And that is when you have, that's the tailwind. So that's R plus W. The rate of whatever the plane is going plus the wind lets him go 600 miles in 3 hours. Okay, now if against the same wind, against the wind, the Piper can fly the same distance, so the same 600, in 4 hours. So that would be the R minus W. So he's going slower. That makes sense. The wind is causing the regular rate to be decreased. So find the effect of the wind and the average speed. We need to find R and we need to find W. Okay, fine. We know that R times T equals W. Oh, excuse me, equals D. I hate that I wrote it like that. I wish I wrote it 4R minus W equals 600. I'm happier with that. And I'm gonna follow. And by the way, these have to be considered in parentheses, which is what we did in the beginning of the year, kids. So I'm gonna rewrite this equation here. Ooh, sorry about all the mess. Into 3R plus W equals 600. Now I could do the distribution step. I think what I'm going to do though is just make my lines. These are my two linear equations, my two equations. I could reduce them. This thing in parentheses times 4. So what if I divide this side of the equation by 4 and this side of the equation by 4? That becomes, sorry for the mess, R minus W equals 600 divided by 4 is 150. And this equation, sorry, I know this is insane. I'm sorry. If I divide each of these by, so this one was divide both sides by 4, and this one is divide both sides by 3, so that this 3 cancels. So you end up getting R plus W equals 600 divided by 3 is 200. So these are my two equations right here. One equation, R minus W equals 150. Two equations, R plus W equals 200. And guess what's going to eliminate if I add these two together? The W's. The W's. So I end up getting 2R equals 350 when I add these two numbers together. And that means if I divide both sides by 2, then R, because these cancel out, equals 175. So miles per hour. So the actual plane is traveling 175 miles an hour. Yes. Now I want to find out the effect of the wind. So I just plug it into any old equation. I've got a million equations I can use. I've got this one, I've got this one, I've got this one, I've got this one. Let's just use this one. Let's see, I'm plugging it back into this equation. So R minus W equals 150. This equation right there. So R is 175. 175 minus W equals 150. Well, what does W have to be so that 175 minus it equals 150? Well, in this case, W is 25. I can do that in my head. I could have used algebra, but whatever. Oh, miles per hour. So the wind affects him the wind is 25 miles per hour. So with the wind, the dude was going, think about this, 175 plus 25. With the wind, he was traveling 200 miles per hour. And against the wind, he was traveling 150 miles an hour. This is totally understandable to me. I'm very proud of myself. I hope this makes some sense in class. We have plenty of time to practice, okay? I trust you'll figure it out.